if you think about it in hindsight, it's a pretty gutsy move. I would be like, an analogy would be like, I think we have a pretty good volleyball team. Let's go out and play University of Nebraska and see how good we are. Or, pick a team, University of Maryland. Yeah. But, it's like, wow, like, okay, like, if you're going to know how good you are, let's go against a really tough opponent right away.
This is the Leave It Better podcast, powered by the Side Out Foundation. Here's your host, Hall of Fame coach, Janice Kruger.
Welcome to the Leave It Better podcast. Today, we're joined by Dr. Emanuel Chip Petricoin, a pioneering researcher in personalized medicine and co-director of the Center of Applied Proteomics and Molecular Medicine at George Mason University. His work is helping transform how we treat breast cancer, and he has a special connection to the volleyball community through his daughter. She plays club volleyball here at a university, and he's working with us at the Side Out Foundation to do great things. And so, Chip, welcome to the show.
Thank you, Janice. I'm really happy to be here and talk about our work and how the Side Out Foundation is really developing a tremendously cutting-edge approach to helping breast cancer patients live longer.
Yeah. I'm so excited to do this because I think for all of our advocates and our supporters out there that are working hard to help us fund our research. Let's talk about, Chip, how you got connected and sort of the beginnings of your connection here with the Side Out Foundation.
Yeah, it's a really great, somewhat serendipitous, but also I think some, in retrospect, probably meant to happen history here. Bryant Dunitz, I think, had a very tremendously forward-looking vision for how he wanted the foundation to begin to impact patients with metastatic breast cancer. And Bryant had this idea of taking money from Side Out Foundation's, donative enterprise and directly, what's the best, most direct way to impact moving the ball for patients with metastatic breast cancer? The deadliest, what actually causes death in breast cancer is the metastatic disease. And he wanted, how can I make the most direct impact, kind of cent by cent, dollar for dollar? And what he wanted to do was, instead of, funding grants or, doing, bike rides and ending there, right? Coming up with, simply fundraising on the volleyball court was like, okay, how do I take that and derive action out of this in memory of his wife and motivated by his wife, Gloria? And the reason why I'm bringing this up, Janice, to your question, is because he decided to, let's take this money and actually fund a clinical trial wherein we can take the most cutting edge scientific approaches and apply them today to treating patients with metastatic breast cancer. So what Bryant did is he went to the local community oncologists in the Fairfax area and talked to them about, what could we do to make the greatest clinical impact right now? If I could give you, X dollars, what could we do? And my laboratory had happened to be, and still is, very involved in a lot of precision medicine trials with our local medical oncologists in the community. Some of these people are key opinion leaders in their own right. We happen to live in an area where, we're right down the street from the NIH, and where we have these fantastic hospitals, Johns Hopkins and Nova, that are in the area, Georgetown, University of Maryland. It's just a great place to be for patients to get access to the cutting edge therapies. He went to these medical oncologists and said, what can we do now? They said, we need to bring in approaches like in Petricoin's lab and other labs and let's get going. And so that is really how we started to go, as Bryant's vision. And then he went to the oncologist to say, how do we operationalize this into a very focused clinical trial? And that was the beginning of the flywheel that turned into my work and ongoing work with Side Out.
Yes, love that. Bryant is always pretty thorough and pretty direct and gets to what he's wanting to accomplish. And, for me, I absolutely love that we're in this space and connected with you and what you're doing. And I learned today that, as you just mentioned, you're connected with a lot of different kinds of cancers in terms of your proteomics and research there at George Mason. What is unique about how Side Out is doing the research? Can you talk about that?
Absolutely. It goes back to the inaugural, how we got involved. And I can tell you the common thread to all of this was I've been struck and was struck by the really interesting, immediate cutting edge approach that Bryant and Rick and the Side Out Foundation have to what's the best bang for the buck. The Side Out Foundation, obviously raises material money, the whole Dig Pink, all of their focus is great. But there are foundations that are out there raising money for all sorts of enterprises, all really good, the Komen and PanCan and all of these really wonderful patient advocacy groups. And they all have their business model of how they want to impact cancer patients. Side Out was so unique to me and is still so unique to me because when Bryant was pitching the idea to me about, hey, I went and talked to these medical oncologists, Dr. Nick Robert, who's a key opinion leader in the world on breast cancer, happened to be at practicing oncologist in Fairfax, and so he talked to Rick and he talked to folks like Dan Von Hoff, who are key opinion leaders at the national level, at the cancer level, about what to do. He was like, I want to take all the money, dollar for dollar, penny by penny, and I want to put it into a clinical trial to make metastatic breast cancer treatable. And can we move this into a setting where we can put these patients, almost treat them like a chronic disease instead of a death sentence? Can this be something where we could, through the use of precision medicine, put them in a chronic state of remission? And I said to him, we have a shared goal. I would love it if metastatic breast cancer patients were dying at the age of 109, from old age, right?
Something else.
Something else. And, and so let's, I was like, you had me at hello for it. And so the thing that's unique has always been unique with Side Out is that they have taken they've made a kind of a vision decision about taking the money, not giving it out in grants and distributing it, kind of democratizing it out, which is fine. That's a model. Not, taking it and having think tanks and conferences to talk about what to do or developing white papers, all of which can be appropriate at different points of time, but very action oriented. Let's seize the opportunity. Let's take control. The whole Side Out.
Yeah. There we go. Yeah. All right.
Back control, and let's take the fight to the cancer. And let's do it by a focused clinical trial where we're actually enrolling patients with metastatic breast cancer, getting them access to the most cutting edge technologies to learn the most about their tumor at the molecular level. And let's take that information and turn it into action by getting them the right drug that matches their tumor's molecular defect the best. And let's take the best in science, bring it all together and try to make, and not some 10,000 patient nationwide trial. Let's focus. Let's do it here. Let's try to, move the ball incrementally, but with momentum going forward. And that I think resonates with a lot of people, resonated with our lab as being very action oriented. And that is what is unique about the Side Out Foundation, really. And it is truly unique. I don't know of any other foundation that's really doing this in the exact same focused way as Side Out.
Yeah. Yeah. It's something I'm super proud of. Excellent job explaining that.
Yeah. I mean, look, at the end of the day, right, you can you can look people in the eye and say, hey, the money that you raised is literally going to help specifically metastatic breast cancer patients get better outcomes.
Yeah.
Right.
Yeah.
It's not diffused. It's not, 5 cents of the dollar go. It's like, no, we're taking it directly. Here are the number of patients that we've helped. Here are the clinical trial results. That's the other thing that Rick and Bryant, I think, have been they want the data to get into the public domain. They want the data, I always say, like, warts and all, whatever the data is, if it's negative data, positive data in the middle, they want it published, they want it presented, and they also want the data that's generated from this to be able to help the entire field. And what they have done, which is very, I think, forward-thinking from the beginning, is they wanted to make sure that all of the data that we generate in every clinical trial, site out 1, site out 2, site out 3, all the different legacy trials, that is in the public domain. It's hosted at GMU, at George Mason University. It's on backup servers. And so, but the point was they want it to be that anybody could access that database and use it to help push the ball as well in kind of a 1 + 1 = 3 way, I think, And that's really, there a lot of the public, NCI based, efforts do that, but actually I think SiteOut may have been one of the first to actually ever do it, like actually put clinical trial work in the public domain.
We love being first.
Yeah.
So how does this relationship benefit a university program like yours?
Yeah. I mean, look, at the end of the day, I think that, George Mason University has developed into a real R1 program, a Research 1 program that actually is a categorical program, that says that you have a good deal of funding. You're educating the next generation of students and scientists and the workforce. That says that you have to be a good partner to your local environment, around the university, the regional environment, and the national environment. That's the way the university, I think, thinks in general about its impact is, are we doing research of consequence that affects people in the local area? Do we affect people in the regional area? And are we affecting people at the national area? And obviously in the world, and you would like to be international, right? You kind of the concentric circles of impact. And so how does this help George Mason? Well, it gets the research that is ongoing in the lab to help patients. I mean, to actually help people, in the local area, the regional area, the national area. And, it also, I think, it amplifies on Mason's interest in wanting to do research of consequence, and making sure that, it's not just research that ends up getting, published in nice journals and, makes for, your faculty to get promoted and, and presentation to conferences, but actually, can you look at the mirror and say, what I'm doing, like, is it helping humanity in any way? And I think that that's ultimately why we do what we do, right?
Yeah.
So SiteOut is focused on helping humanity and helping in its own way of focusing on metastatic breast cancer. And so it helps George Mason by applying it in a real world setting.
Every time I visited your lab and listened to you speak and show me some of the areas and things, well, of course, I'm always so impressed, and it's always so wonderful to hear your work there and that we're a part and a partner with you. It's truly important to us.
Thank you, Janice. The hypothesis, right? I'm a scientist. There's always a background.
Oh, yeah.
Hypothesis is that by taking what's called a multi-omic approach, and I think that SiteOut was the originator of the term multi-omics, to be honest with you. And I don't know who to give it credit to. Maybe it's Bryant or Rick, but the idea was we have to go beyond a genomics only approach to solving the riddle of cancer. And not to get too sciencey here, right? But genomic medicine is now becoming the public vernacular, right? It's, we see commercials on network TV about this, is that, with the understanding of the human genome, the initial first, application point of that knowledge was cancer, actually taking the knowledge that we could sequence the DNA, kind of the blueprint of the cell easily now in a commoditized setting where the price of doing that collapsed. So it was inexpensive. That started this engine on being able to profile the tumor of an individual patient. And this is all going to go into the story of why site outs and where we're going next. But we have to go backward to begin. Mm-hmm. The ability to understand the genomic sequence of the tumor first began about 15, 20 years ago through these initial efforts. 15, 20 years ago, if a patient wanted to have their tumor profiled, they would have to travel to MD Anderson or Memorial Sloan Kettering or, one of these cutting edge cancer centers to get that done. It was 1 in 100,000 patients were getting it done because it was so cutting edge and so inaccessible that no one was really doing it except at these small places. It was not democratized, as they say, not decentralized. Mm-hmm. So that effort started and it became more and more democratized. And then companies came in and started offering the ability to do it. And then it was any patient anywhere could have their doctor send the tumor to a company or a location, have their tumor sequenced. 10 days, the sequence came back and said, here's what's happening in your tumor. And that started the revolution in precision medicine. And there was this whole series of drugs that came out tuned to, hey, when this patient's tumor has this genomic defect, this drug works the best. Yeah. And that was kind of what precision medicine was for the past 15 years. What's happened is that as people started, stomping those grapes and seeing the effect of that, they realized, man, it definitely helps, but we're missing people that could respond to these drugs. And also even patients whose tumors have these defects, they get imperfect results. Some patients don't respond very well that should. And so they were obviously we're missing something. And so as new technologies got developed, proteomics, for example, metabolomics is another omic, and looking at different parts of the cellular machinery. Yeah. People could see hey, my analogy is genomics was the ground-based telescope, looking at the stars and mapping it. And then it's well, maybe we get a clearer picture by putting out the James Webb telescope. What we thought was a star, now when we have cleaner glasses, it's 50 galaxies is what we thought was one star, right? And so similarly, philosophically, what we thought was cancer kind of landscape with genomics gave us kind of a fuzzy picture, certainly much better than the blur of just looking up at the stars with our eyes, right? But imperfect. And so multi-omics is taking all these different cutting edge technologies, genomics and proteomics and metabolomics and all these different ways of looking at the cellular machinery at the cancer cell, and then saying we want to know everything about it by using different technological approaches that are measuring different components of it. And then using that information to get the cleanest ability to say, this is what you should take out of the medicine cabinet. For you, Chip, for your tumor, this is the best thing. And what the very first site out clinical trial was testing the hypothesis that a multi-omics approach would be better than a genomics-only approach. And they did it in a specific clinical trial with breast cancer patients because of advice that Dr. Von Hoff gave to Bryant. Say, you know what? This is exactly what you need to do. I agree. You need to take a multi-omics approach. Dan was running genomics-based trials. He was one of the leaders of the Stand Up to Cancer Dream Team. I was part of the Stand Up to Cancer Dream teams with Dan. And so we were learning that, man, actually, when you do take all of this information, it's somewhat self-evident. Most people would say, well, duh, like getting the most clean picture would be, better than getting a fuzzy picture. And it's like, yes, but it was more being able to pick and choose the technologies and have those technologies be mature enough to be used in the clinic. So what side out one was test the hypothesis. Do we get a better outcome for breast cancer patients that are dying of their cancer? And let's be clear, metastatic breast cancer patients that's the fatal cause of the disease. And what we want is we want those patients to be dying at 108 of old age, right? So we're pushing that out. So let's go after a very, very difficult group of patients that are very sick. Their disease has taken a toll on them. And what we said is, let's see if we can help this group by a multi-omics approach. If you think about it in hindsight, it's a pretty gutsy move. I would be like, an analogy would be like, I think we have a pretty good volleyball team. Let's go out and play University of Nebraska and see how good we are. Or, pick a team, University of Maryland. Yeah. But, it's like, wow, like, okay, like, if you're going to know how good you are, let's go against a really tough opponent right away. And that's actually what the very first trial did, is like, let's just see if we can be better than a genomics only approach. And it turned out we're much better. That when we looked at the final results of the clinical trial, it was only on about 50 patients, right? But it was very focused hypothesis. We said, if we look at these 50 patients and we compared their what's called progression-free survival, which is how long they live without having to change a drug when they don't progress. So at progression, usually change a drug. And what we did is we looked at their previous progression-free survival interval on a genomics-only based treatment decision. So, okay, this was their interval for what happened to them when they had a genomics-only based therapy. Now let's use multi-omics and decide their next therapy. Now, usually what happens with breast cancer patients at that setting is that every time they progress and go to the next therapy, their interval actually shrinks. The usual kind of rule of thumb is, and it's changed now, but the usual rule of thumb was like, the best response you'll get is usually the first response you have. And every time you progress, the interval gets shorter and shorter and shorter of your progression, because the tumor is evolving. It's gaining strength by kind of overcoming the previous drug. What we did is like, let's actually say, nope, it's not going to shrink. We're actually going to increase the interval by at least 30%. That was the initial objective. People thought this is insane. It's not going to make any difference. Nope. 60% of the patients had an increase of 100% increase.
Oh, gosh.
It wasn't just like 30%. It like doubled for like 60% of the patients, doubled their progression-free survival. It completely, blew the water out of, it was like a abject success. So then Side Out 2 said, all right, let's expand it to do a multi-site clinical trial across the United States, not just 2 sites here in the Fairfax area. Let's go nationwide. And let's see if we can continue to get this kind of increased response in even a larger number of patients. And we did. So then Side Out 3 was, let's see if we can take this approach and apply it to the highest frequency type of metastatic breast cancer that exists in the world. And that is what's called HR positive, HER2 negative tumors. So in breast cancer, we categorize breast cancer into 4 subtypes right now that almost every breast cancer patient is intimately familiar with.
Yes.
Whether or not you have estrogen receptor, like your hormone receptor status, and whether or not you have a protein called HER2 expressed. So every breast cancer patient falls into either my HR positive, HER2 positive, or HR negative, HER2 negative, or HR positive, HER2 negative. So there's four subtypes. And every breast cancer patient knows this, like they know their zip code and social security number, right? This becomes part of their knowledge base. 75% of breast cancer patients, or thereabouts, 70%, 75, are what's called HR positive, HER2 negative. By far and away, the largest group of patients. My mother had breast cancer, fortunately caught early. She was HR positive, HER2 negative. And because of that, she and many women like her would get estrogen receptor, anti-estrogen receptor therapy, like tamoxifen, because they were trying to shut down that hormone receptor. And that was the chemotherapy that every breast cancer patient, normally got. Well, there were new drugs that were approved for HR positive, HER2 negative disease, called CDK4/6 inhibitors. And these are, because you'll see this on TV, palbociclib, these drugs that are in everyone's TV all the time. CDK4/6 inhibitors, that's the drug that these patients are getting for their HR positive, HER2 negative disease. There's almost 500,000 women living with HR positive, HER2 negative disease. Massive. So SIDE-OUT 3 said, we have the stunning results from SIDE-OUT 1 and 2. Let's take this same kind of gun turret that we've built and let's tune it to the most prevalent breast cancer group. SIDE-OUT 1 and 2 were all comers. Didn't matter. We would,
Okay.
Now it's like, let's focus on this HR positive, HER2 negative breast cancer group that are getting CDK4/6 inhibitors. Because right now, CDK4/6 inhibitors are given to every HR positive HER2. It's standard of care.
Okay.
But we know, so it's approved, it's FDA approved. But what we found is that not we, the general we here, the scientific we, found that it does work, but unfortunately, it doesn't work in about 60% of women actually respond, and about 35-40% do not respond at all. It's like giving them water. And yet everyone's getting it initially. And you kind of wait for non-response, and then it's like, okay, now we got to do something else. There's no upfront way to predict who's going to respond or not. And this is a huge deal because there's other drugs that the physician could give other than CDK4/6 inhibitors for patients that are destined for non-response. We just didn't have a predictor. We just didn't know. The field didn't know. So we were like, well, let's see if we can take this SIDE-OUT gun turret that has done so well in our war on cancer in SIDE-OUT 1 and 2, and let's apply it to this question and see. Our hypothesis is that we would be able to identify a predictor who would respond. And we did. We actually found a signature for patients that was highly predictive. We could discriminate almost 90% of patients that are destined for non-response right away.
Wow.
Up front. And then the signature itself uncovered what drug to use for the patients that you didn't respond. Because, sometimes in science, it's like, we have a signature that can tell you that you're not going to respond. But if I'm a patient, I'm like, okay, so what do I get? Like, you put me in a little conundrum just to tell me I'm not going to respond to something, but can you tell me something that will work for me?
Good question, right? I need an answer.
Yeah, I'd like an answer. Like, what now, doc? So really wonderfully, the very signature itself for non-response was the activation of a pathway called AKT.
AKT. Okay. All right.
Protein, AKT, when it's activated, it causes the CDK4/6 drugs not to work.
Okay.
Guess what? There are FDA-approved AKT inhibitors.
Okay. Yeah.
Yeah. So there's
Smash it.
Yeah. So now a physician can understand, hey, are you Mrs. Jones, are you going to respond or not to CDK4/6 inhibitor? If you are, great, we got a really good drug for you. If you're not, we have drugs that will work for you too. And that is a great kind of path for patient management when you have the ability to what we call actionability. No matter what you find, you have an answer for those patients to try.
Yeah.
And so that came out of SIDE-OUT 3 was a major finding. And now we just published a paper literally a month ago in the British Journal of Cancer, a very high impact journal, that we validated this finding in an independent set of samples from SIDE-OUT. And we proved that finding wouldn't have been found with a genomics-only approach.
Oh, double good. Yeah, right.
By kind of a multi-omic based approach, incorporating proteomics into the signature. So, so where are we going with this?
Yeah,
I think we are now at a point where we can really imagine patients getting access, and by the way, the ability to measure these proteins and multi-omic approaches, because of efforts like through SIDE-OUT, have gained traction, credibility, right, in the literature, that this is really true, right? Because we're publishing and presenting and allowing our data to be out there for the world to pick apart. Be careful when you provide all your data in the public domain, because people will pick it apart, and that's okay.
That's all right. Yeah.
Right, yeah. So because of that, it actually has allowed the technologies to become so developed and credentialed and matured that now we have these technologies in the commoditized domain. We have companies now that have formed to run these types of multi-omic approaches that didn't exist before. We have doctors ordering these tests now that, before that, they were only able to patients were only able to go to Memorial Sloan Ketterings or MD Anderson's, but they can have their medical oncologist down the street get access to that same data. And what I've talked to Rick about is, I think, now we're really ready to open very large nationwide trials in partnership with a lot of these big cancer centers to run very large studies now, because the bits and pieces, I would say SIDE-OUT 1 and 2, if you think about it, again, maybe philosophically, we kind of duct taped the engine together and we imagined the engine. We built the engine and we were like, okay, well, we haven't manufactured the part to fit the pipe on here, but we're going to duct tape it together just to get it to run. And then we're going to test to see if even just the engine running works. Yes, 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 yes. So now we have the field has made the real parts to the engine, because our success has illuminated that, hey, what we've done, Janice, is I think SIDE-OUT has de-risked a lot of the, is this hypothesis, is it right or wrong? Their hypothesis was correct. We need to go beyond genomics. We need to go into multi-omics. Well, what kind of technologies do we need? Well, we kind of, we bits and pieced it together. Now we know which technologies work to actually give us the right information. And companies have evolved to fill that gap. So now SIDE-OUT doesn't need to raise money to duct tape together. It can just take the money and deploy it into actually the big clinical trials now. And I think you actually will get an even bigger bang for your buck, because you don't have to duct tape. And, well, now you can just kind of we have an engine. We know how the engine should be constructed. The pieces exist. They fit together. And now we're going to deploy it, and we're going to take the car around the racetrack. We don't have to figure out, can someone out there, bring us some tires for our car? It's no, the tires exist. We know what tires to use, and we know what kind of car that we need to bring around the racetrack. And now we can do it. It's cheaper to do it now than ever, which means more patients.
Yeah. Is this, this is fairly new, right? So the oncologists out there, how much of the knowledge base of an individual who has metastatic breast cancer and who is going to an oncologist that maybe, would there be oncologists that wouldn't know this or maybe not prescribe to this?
It's really interesting. And we could maybe have a 7-hour podcast just on this topic alone.
Sure.
So we'll condense the discussion down a little bit here. But it's really interesting. So the entire precision medicine field now is in this assessment phase, because a lot of the trials like SideOut have been successful, and we're kind of, through efforts like SideOut, we're really kind of illuminating the road in front of us instead of just driving darkly down a backcountry road and just taking our chances. We kind of see the landscape in front of us, but there's still operational issues that are built in. Some of it is hardwired into the way that medicine is practiced in the United States. Some of this is the fact that many community oncologists that actually treat 95% of patients with metastatic disease, like metastatic breast cancer, they're treated at the community level, not in the Innovas or Georgetowns or Hopkins or MD, these, but they're treated at the local, community private practice physician. And those physicians are overwhelmed with patients, right? And some of this also has to do with how, these the field is kind of consolidating. There's a consolidation in healthcare around bigger groups, U.S. Oncology and American Oncology and ION, and some of these big and Innova, are condensing and consolidating for very good reason, to deliver kind of more consistent care. And then that they have enough patients, they can bring in things like a proton beam to be able to give, the best therapy to patients, because there's enough patients there. They don't have to go hunting, right? But the problem is that these community oncologists, for the most part, are overwhelmed, oversubscribed. And also what's happened is the scientific knowledge, multiomics, for example, humans learn like in a linear fashion, and the slope of that depends on the individual. Sometimes I'm like this, but science is like this. It's logarithmic. And so what's happening is that humans can't keep up with the information. Doctors cannot keep up with cutting edge information. There's new FDA approved drugs coming out every day. There's new biomarkers that are being approved. There's new technologies that are being developed. There's efforts like the SideOut, through its cutting edge work, delivering kind of this like illumination to the field, like, hey, we're seeing massive change. But doctors at the community level have a hard time accessing it, incorporating it. And it's the data interpretation side. Like, how do I take all this data and make something meaningful out of it? And so there's efforts, one of SideOut's partners, Prothera, a company that I helped to co-found, is developing treatment decision support tools, kind of a report that aggregates all this, massive information into kind of a ranked therapy option for patients, doctors to basically be like, I got 15 minutes, I'm meeting with this patient. I got a stack of, their medical records this big. I got, proteomic information and genomic and all this stuff that I'm having to kind of think about to make a care plan to talk to my patient about. It can get overwhelming. And that's just the stack's going to get bigger and bigger and bigger with more information. So the field is trying to evolve ways of developing efficiencies for the doctor, AI-based tools.
Sure.
To help, the physician gain efficiencies. So efforts like what Prothera is doing and other companies trying to help the doctor condense this into, a single page. I can look at it. I'm still making the treatment decision. I'm still in charge, but it helps me to gain efficiencies, right? Instead of having to think about it for 5 hours and do my own background research, I can take less time and do it. So these fields are evolving, because what we're finding is that there are still patients out there that are being treated in the community level that are not getting molecularly profiled at all. They get molecularly profiled, but the physician doesn't know how to interpret it, or they may have only seen that specific type of molecular defect one time, or perhaps never, because sometimes these molecular changes occur very infrequently, but when they occur, oh boy, that means that this patient will respond 100% to this drug. But the physician may have never seen that ever in their lifetime, that molecular defect. They don't know what to do with it. And so the field is trying to gap fill those things. Now that we get molecularly profiled, our molecular profiling is commoditized, multiomics is becoming commoditized. We have studies like the SideOut Pioneer to show that when you do it, people live longer, healthier lives. You have things like SideOut 3 that show that we can even get this to patients that have the highest incidence of a specific type of cancer and help them to get on the right kind of therapy. Now, I think the field is trying to figure out is that last mile problem. How do we deliver the package to the house? Mm-hmm. We've gotten it from across California and we've gotten it to the UPS. How do we get it to the home? How do we get the package that last mile? And that's where the field is, I think, kind of trying to figure out what we call the last mile issue with getting the right, we think about right drug, the right patient at the right time. Everyone says it. It kind of, I've heard it enough. It starts to I go, bat crazy hearing it.
Okay.
because it becomes a thing to say, but to do it requires a logistical daisy chain of things that you have to operationalize. And that's kind of where we're going at now. That's one of the biggest issues I see where the field is trying to solve right now.
Well, at least they're saying that, though, right?
Oh, yeah. No,
I mean, that maybe that's the start. It's just.
Yeah, I was, I'm involved in a lot of molecular tumor boards.
Okay.
Molecular tumor boards are one also part of the ecosystem that's evolved now, for cancer patients. So these molecular tumor boards have evolved to help physicians kind of battle the overwhelming information load that they're seeing by, hey, let me talk to my colleagues and let's have a group think about this. Here's my patient. Patients are presented. And then they get all of their contemporaries to say, well, if this were my patient, I think about this and this and this and this. That's a great collaborative way to get everyone's brain together so that at the end of the day, the patient is I actually have 15 doctors looking over me.
That's a good thing.
It's a good thing, right? And so when I've participated in these molecular tumor boards, I've really learned that these physicians are, these oncologists want the best drug for their patients at the right time.
Sure.
They absolutely want to do the right thing at the right time for their patients. It's just the operationalization of that for every single patient that the field is kind of at. So I referred, friends and family just through my own, everyone is touched, I think, either knows somebody or has a family member or knows somebody who knows somebody that is battling this disease. I have as well. And so I've told folks that I know personally, there is no better time than now to have gotten this disease. I'm very sorry, right? This is horrible. Nobody wants to have that diagnosis, but you pick the best time to get it because there has been no better time to have had the greatest armamentarium of bullets in the holster for the doctor to use. There's lots of therapies now, and there is no reason to think that you won't live very long periods of time if we can get you all that, get you on the right drug at the right time and get it done every time that you progress. There's no reason to think, there absolutely is no reason to think that we will not have bent the curve for metastatic breast cancer and other diseases, other metastatic diseases into a chronic condition. Mm-hmm. I really believe that this will be the next phase of oncology, will be treating cancer as a chronic disease.
Mm-hmm. Yeah. To me, the medications give you that length of time and the findings and the developments and kinds of things that could pop up, for you,
And look, let me tell you something for your listeners to get even more excited about and not kind of irrational exuberance. But we're finding that if we can get patients on the right drug at the right time early enough, and I'm not talking about like precancer like we're doing with colonoscopies, which are wonderful because of their prevention, but actually even patients with metastatic disease, like metastatic breast cancer, if we can detect the metastasis early enough and we can get those patients on the right drug at the right time, there are trials right now that are testing whether or not we have been able to cure the disease, because we have women. So there are women that have been living with their breast cancer decades, even with, old-fashioned therapies from the 1990s, right, and early 2000s. There are women that have been living for 20, 30 years with metastatic disease. And what we're doing now is we're learning, we call those women exceptional responders. So we're learning from these women and men, why did you do so well? And we're actually going back and reverse engineering that, and we're learning a lot. And so I think you're going to see in the next 2 to 5 years, the fact that we're actually clinically curing some of these women, where they're able to actually go off of their drug and live their lives and maybe, come back in for an MRI in 5 years, right? Just to kind of put you on a surveillance. And I think that's going to become more common. It's the iceberg right now, but I think that this is a very optimistic time. It's a very serious time.
Yeah, sure.
I have loved ones who are battling metastatic disease, and it's a hell. But this is the best time. If you were diagnosed with cancer, this is the best time to have done it.
Well, that's, I love hearing that. Lots of promise and potential and exciting news.
You need people like Side Out to push the boundaries. You actually have to have, in the fight, you have to have people who are willing to kind of go up the hill first. You need those people, right, to take the hill first. Someone's got to go up first. And you can't be looking over your shoulder and pointing to each other and saying, who's going up the hill, And that's something that Side Out has done from the very beginning. And you need that. You need those people that are going to take that cutting edge approach, that cutting edge risk, and test cutting edge hypotheses, not timid. Like I said, you went out against, you took your practice team and you went out against a really good D1 team right off the bat. And you held your own, which is amazing. That first trial, people were amazed by. Mm-hmm. I can't say it enough. It was that a lot of people did not think it was going to work.
Well, we're on a mission, and we're going to keep driving this until we'd like to be the one getting up that hill and having the support and the advocates that know about us, support us to continue going up the hill to find more information, to do more for people. So,
yes. Thank you for all the work that you guys are doing on that end, because we couldn't have done it without you.
I find a lot of times, unless you have had breast cancer connection somehow, that you would know what the term metastatic actually means when somebody says that they're in, the different stages, of course, but metastatic. And
let me tell you, the difference, all the different stages they talk about, are important, stage 0, stage 1, stage 2, stage 3. But the difference that's night and day is whether or not you have metastatic disease or not. And what does that mean? It means that the cancer, the cells, have left their happy home and have traveled outside of their happy home and have taken up residence in other parts of the body. And the biology 101, we have the cells in our body. We have epithelial cells in the back of our eye, for example, right? Help us see. Those cells don't leave the eye and go into our mouth and become part of
okay.
They're not just traveling around constantly. They have their job. They're there. They do their job. Normal cells stay where they're at, and do their job. Cancer, when it evolves, is like a little mini terrorist. It's like your own cells have accumulated enough genomic mutations that the cell's like, hey, I actually don't need to stay around. I mean, the cell doesn't have a brain, right? But the cell takes on attributes like, hey, I can detach here and I can float around and I'm not dead yet, because usually normal cells, as soon as they detach, they die. What calls contact inhibition.
Okay.
The way we've evolved. So like, it's not like our cells in our entire body aren't moving around doing other different jobs, right? So in metastasis, the cancer cells have the ability to leave where they were originally from. Say your breast cancer, the epithelium, the actual cells that cause cancer are in the duct of your milk glands that humans have, both men and women. And that is to do the job of actually making milk, right? That's the job of those cells there. And they'll do it at very specific times in human existence, right? And that's their job. And they're just hanging around waiting to do that job. When they've accumulated genomic defects that makes them cancer, they can leave that their happy home and actually travel into the duct and then into the bloodstream. And then if those cells can like survive and start growing in the liver or in your brain or in their chest wall, they're not supposed to be able to do that. Like that and that happens. Our cells detach all the time and they're immediately die and killed. It's happening to you and me right now, Janice, and we don't even know it. Our bodies are working in a normal way, right? Cancer, when it metastasizes, that cell leaves it and it goes and travels to a distant site. And then it keeps growing. It's like, hey, this is great. Not only do I not need to stay in my happy home back in the breast duct, but I can take up residence in the brain, and it doesn't know it's in the brain. It doesn't it's just growing now. It's just growing inside the brain that kills the patient. Mm-hmm. Or it takes up residency in the liver and it grows and it kills the patient because it destroys the liver. Again, these cells don't have brains. They're not thinking. It's like, okay, now I can do this. And it's just, I'm going to grow here. And it's terminal. At the end of the day, it's like, stupid because you're going to kill the very thing that you're growing in, and then you're not going to grow anymore either. So
yeah, come on, cancer. Figure it out.
The point is like that when that happens, no one dies of local breast cancer. That doesn't kill the patient if it's confined to the breast. There's other issues, believe me, right? That are tremendous morbidity and for sure. And we want to prevent that from ever happening. But what kills the patient is the metastatic process. That's the lethal aspect of cancer. And because the side out is focused on metastatic breast cancer, you're taking on the toughest opponent. That tumor has evolved to be the most aggressive, most lethal. But that is what is the tip of the spear. You're actually taking the spearhead off if you don't have metastasis. It's just a stick. So you guys, by focusing on metastatic breast cancer, are going after the very, very thing that causes death in patients. And, the trials are about staving that off or eliminating it.
Yeah. Thank you for that. I think Gloria Dunitz, being the very first patient within our first clinical trials, says a lot about the Side Out Foundation too, that we believe in what we're doing.
I guess one thing I would say is that that I learned from working with the Side Out Foundation was that, there are big foundations out there, Avon, Komen, that are in the breast cancer space, American Cancer Society. They're very large foundations, all doing, God's work, if you will, all doing the good work of trying to help out, these patients. But what I learned is like the Side Out Foundation, by being focused You don't have to be like an aircraft carrier size foundation. But by tapping in the energy so effectively of a sporting event, it was really interesting to me to see that, like, that turn, that, you know, that crank turning of how to take that energy and passion, you know, in a sport like volleyball, and then like focusing that energy like a beam of light onto this problem can make a difference. Like, you can make a difference. It is not just something to say. It's not like a nice, you know, slogan to have. Like, it actually does work. And I learned that. Like, I don't know if I was, but I might have been skeptical that was possible. But I learned that this is really possible. So I don't think for your constituents, it is not self-evident. This is the fact that you're doing this is really something quite special. And I think, I hope you guys can continue to do this in the same way, because it really is making a difference. And your constituents should know it actually does make a difference to patients' lives.
Mm-hmm. Well, thank you for that. I've been a volleyball coach for 50 some years. I love the sport of volleyball. I believe in the folks that play it are just pretty special. Yeah. And we definitely love working with them. And I appreciate you saying that, because that's just means a lot to us, Chip. And all the work that you're doing there with us, for us. Thank you.
Thank you.
Thank you for listening. Please share your feedback with us at side-out.org.